So let me share my screen and share my slideshow here. All right. No problem, Josh. I'll fix it if I didn't. Oy. Boom. All right. So we're going to talk about moments today real quick. And honestly, the assignment for moments is not a good one. I really don't feel like spending too much time with the assignment itself. The next thing we do with trusses are going to be very, very, it's going to be a challenge. Honestly, it's probably the tougher math you'll have to do. And I'm going to try to keep it simpler this year, especially. But the math will be, there's a reason. This is unit 2. And as you notice, we did unit 3. No, we didn't do unit 3. I usually do unit 3 before unit 2. This year, we go so slow because of everything. We're just following natural order. Here we go. All right. So moments. Where's my mouse? There. Okay. You don't need to copy all this. I'm just going to run through it real quick. So moment and torque, and I know I've already covered moment before. Okay, so I'm still talking moments. You have seen it before, but we didn't apply much from it. But moment is just going to be force times the perpendicular distance away. Okay, so you got some kind of force being applied. Yep. That's your pivot point. So you got to always look at where the pivot point is. The reason you need to know where the pivot point is that tells you how far away you're applying the force. And that's going to be your distance. And the distance always has to be perpendicular to the force, always. Okay? All right, so moment is just going to be distance times perpendicular force, or distance times force. Now, any of you math nerds out there, if you're taking calculus, this is actually where if you see the cross or the multiplication time that we all, our sign for multiplication, the time signal or symbol that you've always done, that's actually a calculus. That's different than multiplication in other ways. Because if you have, that's actually called a cross product. You don't need to know that. But believe it or not, when you do multiplication with an X versus multiplication with a dot, in calculus, they actually mean two different things. And here, it's important that they use the X because when you do cross product, they have to be two perpendicular things being multiplied. Okay? For some of you, whenever you head, and that's fine. I just want to point it out so I look smarter. All right. Next. Here's different units. I don't really care so much about that. Now, when you have something rotating, I know I remember talking about this. You want to be thinking about how things rotate on the paper. So when you look at your paper and you see the way it rotates, I want you to put a thumb on it. Okay? And rotate it, you're going to curl the way your fingers are curling. Okay? So you either got clockwise or counterclockwise. All right? So clockwise, everybody put your hand on the screen and curl your fingers. Your right hand, it has to be right hand. This is because it's called the right hand rule, not the left hand rule, the right hand rule. Okay? So put your hand on the screen, your right hand on the screen, and curl your fingers the way that it's direction that it's turning. Okay? Now, if the screen is upright like mine, it might not make as much sense, but imagine it's flat. Okay? So if I curl my fingers counterclockwise, all right? I have the screen down, I turn, I'm giving a thumbs up. If I give you a thumbs up, am I giving you a positive review or a negative review? Positive. Thumbs up means positive. So if I curl my fingers, my right hand, counterclockwise, it's a positive moment. Okay? If I curl it clockwise, okay, think about it being flat, clockwise this way, I'm giving you a negative review. So that's a negative moment. Okay? So that's how you remember. It has to be right hand. It cannot be left hand. All right? And if you're not sure, left makes an L. There you go. All right. So that's why we call the right hand rule. Up positive, down negative. They also say towards you. I mean, I just think, make sure this, pretend the screen's flat. Flatten it out. Curl and thumb, counterclockwise, clockwise. All right. Wonderful animation to show what I just showed. All right, right hand rule. Is that going to be a positive or negative that we just did?
Positive.
Very good. I'll show it again in case you weren't paying attention. Right? Went clockwise. Use your right hand. Curled it. Positive. Okay. Opposite direction, so you know it's negative. There you go. All right. Now let's do calculations. Really easy, right? I got force in pounds. So in here we do pounds of force, and we do feet. So if you ever have your car, if you're going to attach, because moments basically similar, pretty much the same thing as torque. So we measure those in foot-pounds. That's because if you buy or if you're going to attach lug nuts, when you put the lug nuts on a car, you have a special rating. You don't want to over torque them and stretch out your bolts so they snap off, which happens. You don't want to under torque the lug nuts so they are loose and fall off, which happens. You want to make sure you have the right amount of foot-pounds, okay? In engineering, we're going to measure moments in foot-pounds as well, all right? So is the answer going to be 20 times 9? No. The answer would not be 29 times 9. Why not? Somebody blurt it out. Don't put it in chat. Why am I not going to do 20 times 9 to get my moment here? What do I measure in? What did I just have a whole lecture about mechanics? What do they measure in?
Foot-pounds, and that's inches.
Foot-pounds, and that's inches, exactly. So you need to convert inches to feet so that you can do this calculation, right? So that's why when you do the calculation, it's going to be 0.75 for the feet, or 20 times 0.75 for the moment. And notice they gave a negative answer. Why did they give a negative answer? Because the moment is going to be negative, right? We got a negative moment. If I see this force here and I see that pivot point, stick your thumb at the pivot point, curl your fingers, that's negative moment. So that's why we have a negative 15 foot-pounds. Okay? The positive and negative is going to be important here. Okay. What is the torque going to be here? Give me an answer.
20.
Is that your final answer?
Yeah, I think so.
So, yes and no, right? Yes, the number is 20, but it's negative 20. Because again, We gotta be going that. Now, would I be a stickler with it? No. And I appreciate Munib for answering while everyone else was silent. However, when we do our addition, we're gonna do a sum of forces and sum of moments. And if we're gonna add two moments together, we got to make sure, you know, that they're added properly. And if we have one's positive, one's negative, and we accidentally add them both as positive, we get a wrong number. Okay, so that's why I'm pointing out that this still should be a negative 20 foot-pounds. Okay. All right. Now, I don't have. Do we have a length here? So here we have that length. In this case here, now one thing is this picture is kind of dumb because if you push to the right the way force is going, the wrench would just slide off. Does that make sense? But I want everyone to take a minute or two, and I want you to calculate the moment that you think this is going to be. So go ahead and calculate the moment of this 20 pounds of force, including sine. Okay. So let's look it over. So moment is going to be, first of all, we already see, they already have the symbol, right? We have negative, so it's going to be a negative symbol or negative moment. So the distance we are going to use is only the perpendicular distance. So the only perpendicular distance is at 3 inches. So it's going to be 3 times I'm sorry, and not 3, but 0.25 times the 20 pounds of force. Okay, so we should get our answer, which would be a negative 5 pounds, our foot-pounds, negative 5 foot-pounds. Okay? All right. Next. All right, different wrench. Go ahead and calculate what the foot-pounds of the moment in foot-pounds is going to be for that. In a minute, I'm going to have you all enter in your answer. So don't hit enter yet. I'll tell you when to hit enter. Are we ready? All right, go ahead, hit enter. Type it in. Yeah. Okay, good. So again, good job, everybody, putting in answers. Again, I would say it should be negative, right? Because it's a negative 30. But we're just going to be doing 18 divided by 12 to get our number of feet. So, right, because the total distance, that it's still perpendicular, 18 inches perpendicular times a 20. So we should have 18 divided by 12 is a foot and a half. And you get your distance, or you get your moment. Okay, so the 9 inches means absolutely nothing here. All right. How about now? Go ahead and do that one. Okay. So notice that's the radius, not the diameter. Okay. Now this one's actually in newtons and meters. Whoop, wrong way. So we got meters. Honestly, I don't know why we're doing Newton meters to bounce back and forth. There's no reason to. So Newton meters, and we could do a conversion to foot pounds. I wouldn't worry about that though. Okay. Now, what about that on angle? That's tricky. So if we have something like this, it's only the perpendicular piece that's causing the rotation. So in this case here, you would have to do sine, cosine. You have to do your SOHCAHTOA. Notice we got our angle with respect to the horizontal. All right. Is it going to be a y force or an x force that's going to get us the perpendicular force?
Y.
Yeah, good. Is that going to be sine or cosine of 50 degrees then?
Sine.
Good, sine, because it'll be the force of 100 times sine, because that's the piece of the force that's perpendicular to it. Okay? But again, I really don't know why they want to bounce back and forth between meters and inches. But yeah, so sine is what we got. And so the force, they do the force right away. They do 76.6 newtons is the force that's actually being used for the moment. Okay? It has to be that component. All right. Now, with equilibrium. So remember what we did? Remember that fancy letter we did for sum, right? I'm going to draw it over here. It's on the board as well, but I'm going to draw it to make myself look like a fancy lad. If I can find my marker. All right. So remember what we did for sum of the forces. With equilibrium, whether talking about forces or moments, there's a whole idea of the equilibrium. So the sum of the forces the sum of the moments, if they add up to 0, the object doesn't rotate. All right, so what we're about to do is we're going to say, like, talk about a bridge or something. Or let's say I just have something basic like that. Okay, that's my bridge. Like it? It's a really nice bridge. Okay. What you would do is this. You would say, we have 2 pivot points. We have a pivot point here, and we have a pivot point there. Let me just call this A and call this B. Okay? Well, think about what's happening. At A, you have a moment because this part of the bridge is going to be pushing down. So you basically have a rotation here. That's going to be the moment A. Okay? The other side, the weight of the bridge is trying to push that part down. So you have going around B a pivot that way, which is going to be a moment B. Let me take a step back and let me do that again just to explain what I'm doing. Okay? You have a bridge. It doesn't really matter if I got a pin and roller, but I got a bridge right here. All right. I have one pivot point would be basically here, and one pivot point would be there. I'm going to call this A. I'm going to call that B. The bridge, if I have this pivot point here, one of the pivots that could go around would be the bridge would circle around A. So that would be the moment at point A. So the moment at point A, I just write MA, okay, is the wanting to rotate in that direction. Okay? Now, what about B? B, the bridge would want to spin around this way because the weight of the bridge would cause it to want to spin around that way. All right, so we have another moment that's going this way. And that's going to be the moment B. All right. Which one's positive, which one's negative? Is A positive moment or a negative moment?
Negative.
Use your right hand.
Oh,
Negative.
my bad.
That makes sense? Because pretend this paper's down, but it's clockwise. Clockwise is negative. All right. B, is that positive or negative?
Positive.
Positive. Okay. So now let's go to what we have on the board. We have this fancy pants lettering of sums of the masses, or sums of the moments, rather. Okay. So if I wanted to look fancy, okay, be a fancy lad, I would write the sums of the moments are equal to a negative moment of A plus a positive moment of B. All right. And if this bridge is not rotating, which I hope you are never standing on a bridge that could be rotating, plummeting towards the earth, that means the sums have to add up together. If there's no rotating going one way or another, it's an equilibrium. So the sums of the moments have to add up to 0. Does that make sense? Okay. All right. I'm guessing I'm going to start losing people. I think you did a good job paying attention to that, but I don't want you to fall asleep. I'm not going to go through this right now. And I know I went through some of these before. So you can go back on PLTW if you want to do it. But here's another example. So you'd have a moment. C would cause A to rotate one way. C would cause B to rotate the other way. Okay? So the sums of the moments, what you do is you say the sum moment of one plus moment of the other will cancel each other out. They're going to be, and then you can solve for what you need. Okay. Oh, and you know what? Let me take it back. So this one actually set up slightly different. So what we're going to do is this. When we have, let's say we have two moments to pick. I'm going to take a step back now and do it the right way. You will pick a pivot point. Okay, so I did that in having 2 different pivot points, but that's going to be confusing. So you're only going to pick 1 pivot point. So if I redraw this here, get ready, America. All right. Do we remember what the name of the triangle is? What's the name of the triangle when we draw a truss? You said it right.
Lateral.
When I'm drawing a truss, I got 2 drawings. I either have a triangle or a circle. What does a triangle stand for? Don't remember? Pin. This is a pin, and it has 2 reactionary forces. It has a reactionary force going up and a reactionary force going to the side. Okay? Do we remember what this one is now? What's the circle stand for?
A roller.
Roller, good. A roller only has 1 force. It only fights up. Whenever we do these, so we look at this picture here of A and B, and we want to solve for RB, what they're saying is they're going to make A the pivot point when we do the moments. So A is set for the pivot point. Now, when you do this, when we're given a truss and you have the choice and they don't tell you which one to choose for the pivot point, always pick the pin as your pivot point. Okay, make a note of it. Always pick the pin as your pivot point when you're going to be dealing with moments. Okay, so what this drawing shows is you have C trying to cause the moment to go one way, and you have B trying to cause the moment to go the other way. And it's all but they both have the same pivot point of A. All righty? Okay. All right, and then all this calculation stuff you could do. I'm not going to do right now, but we will do it in a little bit. Okay. Where am I going to have my pivot point in this one? Am I going to have it at A or D? And apparently there's timed animation on it because I'm not touching anything. The pivot point is going to be at A again because that's the pin. Notice that there's 2 reactionary forces for A. There's only 1 for D because D's a roller. All right? And then you do all the calculations. This would be something we want to break down later. All right? Today is going to be a little more basic than this. Okay, I stopped the share. Okay. I need you to remember this piece. A pin has 2 reactionary forces. A roller has 1. There is an equation you are going to get to determine. So we call this static determinacy. That's a fancy word. And I don't know which slideshow it's on, so I'm just going to write it down. This is for your assignment. Static determinacy. And what that means is, if you're given a truss, can you calculate all the forces? And why would you want to go forward and try to calculate all the forces if you cannot? Does that make sense? So if I have something that looks like, I don't know, I'll do this. I don't know, I'm lazy. I want to do it that way anyway. So okay, I got this, and I got that. All right. The equation to figure out, if you can figure it out, the equation to figure static determinacy is going to be this. 2 times the joints that you have, is it equal to the members plus the reactionary forces? Let me try it. So the equation is this. Is the left side going to be equal to the right-hand side? That's what you're always checking when we do this, and this is what you're going to be doing for your assignment. Okay. So this is what I have. I got every point where the members are meeting. Members are just the arms. Members are the beams. Okay? Wherever the members meet is called what? What do you think that's going to be called? Joints. Okay? So we got J stands for joints. M stands for members. And R stands for reactionary forces. All right. I want you to tell me, I want you to type it, but don't hit enter. Type it in, don't hit enter in chat. You ready? How many joints are there in my truss that I just drew? Hopefully you see it. Hopefully you understand what my picture is showing. Are you ready? Type in your answer. Don't hit enter yet. Ready, ready, ready? How many joints do we have? Enter. Okay. Zane Train. Let's count them. 1, 2, 3. There's 3 joints. That's where the members, any place two members are being connected, it's a joint. All right. Get ready again. Type in how many members there are, but don't hit enter. How many members do you see? All right, hit enter, go. Okay. We got 1, 2, 3 members. All right. How many reactionary forces are there? Type it in. Don't hit enter yet. Yeah, I'm going to do this. Reaction. Okay, ready? Go, hit enter. Let's see. A pin has how many reactionary forces? A roller has how many reactionary forces? How many reactionary forces do we have total? 3. All right, let's plug into the equation. Do we want to spend the time? Should we spend the time doing this? Because we'll be able to get an answer. This is why we call it static determinacy. Because it takes a really long time. We probably want to figure out if we can even get an answer. That's what this equation means. So we plug it in. 2 times J. So 2 times 3 is equal to 3 plus 3. Yes. So it is statically determinate. Does that make sense? Your reactions on your faces, the looks on your faces show me you really understand what's going on right now. So that's very satisfying. Okay. All right, people, this is what we're going to be doing for class. You are going to have your assignment is to do the static determinacy assignment, which is, okay, good, it's there. Let me do student view. All right, so if we go to statics, down below you will have the static determinacy. Okay? Do your work in the thing. You're doing those equations. You'll be given pictures, and you'll have to do. You just make the decision. Now, I will say this: before you click it, if I were to say, what if we had this messed up? So let's say that I did. No, let me see what I want to do. Yeah. Oh, yeah, I know what I'm going to do. I don't know how I'm going to do that, though. Okay, let's say we had something that wasn't statically determinate. Let's say I had, that's going to mess it up. Let's say for some reason it was off like this, okay? I had some kind of thing that's crazy. Let's do this one real quick together before you work on the assignment. Let's go and change it so that I have an extra bar in the middle. So now let's see how many joints and members. I'm trying to get one that's not statically determinate, so I'm hoping this one is not. All right, so now how many joints do I have? 1, 2, 3, 4. How many members do I have? 1, 2, 3, 4, 5. Crap, I can't get one that's good. Oh, I know what I can do. Well, what I'm trying to say is this. I'm going to ask you if something is not statically determined, I'm going to say, what can you do? And you say, oh, well, you could add a member. or you could change a pin to a roller, or change a roller to a pin. So I'm going to have these options. The only thing I'll say is this: if you have one that's a roller over here, and then you have another one, you know, that was a pin, and you say, oh, you could change a pin to a roller. If you all of a sudden have two rollers, it would just fall down. Does that make sense? So use some common sense when you answer that part. But I'm going to say, if it's not statically determined, what could you do to make it statically determined? Okay? All right, ladies and gentlemen, that's what you're going to work on today. This is the one on the roller and pin shared. I don't know what you're saying there. Like that. Anyways, okay. All right. So good luck. That's what you're going to work on. Let me know if you have questions, but that'll be what we need to get done today. This is something that should be very fast. Ladies and gentlemen, let me talk to you for a second. You know, closing of quarters are a lot of fun. Like, for instance, the 15 minutes I had to spend for at least probably for each student that sent me an email, sometimes even a little bit past when it was supposed to be due, telling me, hey, Mr. Spudik, here are my assignments. Doing assignments when I give them to you, it's funny how it works, but that's actually way better to do than waiting 2 months later when you don't know the material and have to relearn it because, I don't know, you decided you'd rather sleep than get it done when you had the chance. It's funny how that works, huh? So I just wanted to have this moment to talk to you one-on-one and make sure you know how much easier it is to do something now instead of watching, I don't know, sports or Netflix, or I don't know, going, you know, the back of your eyelids, whatever might, you know, what other options you might have that might be tempting. Let's do your stuff now so I don't have to deal with the late work later. Does that sound like a good idea? I know it does. Okay. Thank you.